Okay, today's lesson is going to be about solving inequalities. And what an inequality is an equation where the equal sign has been replaced by either a greater than, less than, greater than or equal to, or less than or equal to sign. Otherwise, it works pretty much like an equation with the exception of a few special cases. And I'll try to show you one of each of those. Now, I'm just going to start by working a problem, and that way you can see how these inequalities work. And the first one I'm going to work, just a basic multi-step equation. There's a little bit of cleanup that needs to be done before we can solve, but just follow along with me and I'll refresh your memory on that. Now the first thing we do is draw our line, and we're going to work on, in this case, the left side. And the first thing we need to do always is clear out these parentheses, just like when we're working regular equations. So I do that by multiplying what's on the outside by what's on the inside. So I have a negative 8 times a positive 8 is negative 64. Negative 8 times a negative 4n, the sign goes with what's behind it, is a positive 32n. And then on the right side, we still have 0. Okay, I'm not going to deal with this inequality symbol until the very end of my work. Okay? All right, now we have just a basic two-step situation. So I always start my work on the side that has the variable because I'm trying to isolate that variable. So I need to get rid of this 64, so I use the additive inverse. Add 64, add 64. That goes to 0, leaving me 32n on the left and 64 on the right. Now my second step is multiplication or division. In this case, it would be division. So I divide by 32, divide by 32. And I end up with the n on one side, and 64 divided by 32 is 2 on the other. Now, nothing special happened here. We didn't run into any special cases. So I simply just look at the inequality sign that I have and bring it down. So my answer would be n is less than or equal to 2. Now, how do we graph that? Because inequalities, the answers consist of a symbolic answer and then also a graphical answer. Now, you won't always see this number line. You'll have to imagine an invisible number line a lot, but I'm going to go ahead and just make sure that you see what I'm doing. So I'm just going to draw a number line with a few reference points. Okay, so what I've got is my number line, and I have the inequality represented symbolically that says n is less than or equal to 2. So where are those values of n? Well, first of all, here's where n equals 2, so I'm going to make that a dark filled in circle. If it had just been n is less than 2, I would have left that open. The only time we fill in the circle is when it includes the point we're talking about, and we know that because there's this half equal sign underneath. Now, where are the values of n that are less than 2? Well, they're this way. Okay, so my graphical answer would either look like this or simply that. And this just has the imaginary number line under it that you just have to picture in your head. Okay. That's just a straightforward inequality with nothing special, no special cases or anything. Now let me show you one that does have something a little different that we have to be aware of. Okay, so I'm just going to move my paper up and I'm going to work a second problem right here. Okay, starts out normally. Like any other equation or inequality. I still have the job of clearing the parentheses on this side. So I've got negative 7 times n is negative 7n. Negative 7 times 8, negative 3 is a positive 21. And on the right, I say I have 63. Now I just have a two-step situation. We'll call this part a two-step inequality. And the first thing I have to do, always working on the side that has the variable, trying to isolate this in. So the first thing I have to do is get rid of this 21. So I'm going to subtract 21 from this side, and whatever I do to one side, I have to do to the other. So I'm going to subtract 21 from the other side as well. Now, what that leaves me is my negative 7n on the left and a positive 42 on the right. Now, this is a special situation that we have to be aware of. To clear out this negative 7 and to leave this in by itself, I'm going to have to divide by a negative 7 on both sides. Okay, cross those out. That leaves me in. And on this side, it leaves me negative 6. Now, here's special situation number 1. The rule states that anytime you multiply or divide by a negative number in the final step of solving, you have to flip the inequality. So what I'm going to do is I'm going to look back up, realize I have divided by a negative number, and then I simply just flip my inequality symbol in the last step to give me the answer. So I have n is less than or equal to a negative 6. Okay, so how do I graph that? Well, it's less than or equal to, so I'm going to have a solid dot. And then where are my values less than something? They're to the left of that. So if that were negative 6 on the number line, my values of n that are less than or equal to negative 6 are all this way. Okay? So that's the one you're going to have to watch out for. Always make sure you look to see in your last step, did I multiply, or in this case, did I divide by a negative number? And if you have, you must flip that inequality. Okay. Now I'm going to work another problem that illustrates another special case. There's 2 more special cases that we need to go over. And this one is, let's start out with our problem. And the problem is 5x greater than or equal to 5x plus 11. Now these come up most of the time when we're working inequalities with variables on both sides. Because what happens is, we talked about we've got to get our variables on the same side, and I've always said pick the smallest one and move it to the other side, big rock, little rock. Well, look at these. Look at 5x and 5x. They're the same size. But we still need to get all the variables on one side, so we still do the additive inverse. I'm going to say minus 5x on this side, and then I'm going to say minus 5x on this side. Now when I do that, I get 0 on this side, okay? And I get 11 on this side. Now, if this had just been an equation, I would have had an equal sign, and I would have said no solution, because no way does 0 ever equal 11. But with inequalities, it's a little different. You have to look at what the inequality is telling you to do and then decide, is this a true statement or is this a false statement? So let's bring our inequality down. And it says 0 is greater than or equal to 11. Is that ever true? No, this is a false statement. And anytime you get a false statement, then it is no solution or empty set. And we denote the empty set by taking a circle and drawing a line through it. So the answer to this that I would accept would be no solution or draw this empty set symbol. Now, how do we graph such a thing? Well, you can't. There's no graph. You cannot graph anything that says 0 is greater than or equal to 11. So you would just say no graph, NG. So if your inequality makes a false statement at the very end, then you have no solution or empty set. Now, just saying, what if this had been the other way around? What if you'd worked through a problem and it ended up saying 0 is less than or equal to 11? Okay? That is a true statement. 0 is always less than or equal to 11. So that would have been a true statement. And true statements, the answer to the inequality, or the set that makes those true, is all real numbers. So the answer would have been our fancy R, or all real numbers. And then how do we graph all real numbers? Well, we include everything that's on the number line. Okay? So our answer graphically would have looked like this. And to confirm that it's all real numbers or a true statement, this problem won't work because it's actually a false statement. But when you come up with one that gives you something that's true, you can plug any number in for x, and it will work every time. Okay? And that's what makes it a true statement. Okay, so I've gone over just a regular inequality in the first example, and that's where nothing happens except you bring down your inequality symbol, and everything is just as it was in the beginning. I've illustrated a sample where you've divided by a negative number in the final step to clear out your coefficients and leave your variable. And when we do that, we have to flip the symbol. So you've seen that example. And then my other two special cases were illustrated with this problem, where we had a false statement, and that gave us no graph and the empty set. And then we said, what if we worked a problem where the statement was true? And when the statement is true, you have a true statement, your answer is all real numbers, and you graph it by including all values on the number line. So we've covered all of our bases on inequalities. Now the best thing for you to do would be to practice some of these, and I will provide you with a worksheet that will give you some practice. Thank you very much, and good luck with inequalities.